Hi, I'm Natã Barbosa from UIUC, and I will present our paper titled Who Am I? A design probe exploring real-time transparency about online and offline user profiling underlying targeted ads. I collaborated in this work with Professors Wang from UIUC, Professor Blase from the University of Chicago, and my doctoral advisor, Professor Wang from UIUC. To illustrate the problem we studied, let's start with a common use case. Say you're looking for a seat stand desk. You go online, do a search, and visit a few related websites. Not much later, you notice ads about seat stand desks showing up on your social media feeds. Today, users' online search, social media, and shopping activity can be used in profiling. Users are also being tracked on their smartphones, with places visited, physical mobility, and apps used on their phones informing their ad targeting profiles and which ads they see online. Most users are not familiar with these techniques, and with a growing number of profiling possibilities introduced by smartphones, wearables, and smart home devices, users may be surprised when they see an extremely relevant ad, thinking smartphones are eavesdropping on them, and becoming frustrated with ads perceived as invasive. These feelings cause users to develop distrust of technologies and businesses that rely on ad targeting. Most importantly, profiling processes are currently very opaque and only visible via settings most users are not familiar with, such as ad interest dashboards and ad explanations. This means that most times users can only reason about these processes at the time they see an ad, which might be too late if an ad is triggering or perceived to be inappropriate or even irrelevant. Given this scenario, we set out to explore what would happen if profiling processes were more visible to users. More specifically, what would happen if profiling was visible in real time for online and offline actions, showing changes over time, and with clear information about how user actions led to items on their ad targeting profile. Our goal in studying this was to inform the design of future transparency and controls that could help users have more desirable experiences with online behavior advertising in a world of ubiquitous computing. To study these, we designed a system that simulated existing profiling processes and gave users visibility and control over their ad targeting profiles in real time. The system is made of a browser extension for personal computers and a mobile app for smartphones. Here's a quick demo of the system. On the computer browser, the user visits a website about auto parts and gets a notification on the top right about possible profiling from the present action. Clicking the notification takes the user to their own ad targeting profile where they can see profile items, what actions led to those items being added, examples of ads, and options to remove or always be notified about an item. When out in the physical world, the user visits a store that sells ice cream and burgers. They get a notification on their phone about the resulting profiling, again showing what they did that caused the item to be added, examples of ads they might see in the future, and the ability to remove or flag the new item for future notifications. We used a technology probe for this exploration, which is a method used to inspire the design of future technologies. After pilot testing the system with 10 users for several weeks, we conducted a 2-week field study of the system with 25 US-based participants from diverse backgrounds. We used participant interviews, diary entries, and user logs to collect data for the study. During the 2 weeks, participants used the browser extension on their computers and mobile apps on their phones. Let's now go over some of the main findings. The use of the probe led participants to meaningful revelations about profiling, such as learning that visits to physical locations and website visits besides online shopping could be used to target ads. Participants also reported wanting to ensure important aspects of their identities were added to their profiles, such as their gender identities or a strong interest in a hobby. Study participants liked the idea of being in the loop about ongoing profiling and being able to set their own boundaries about what could be off limits for ad targeting. Participants also found the experience elucidating, with some explaining that they started understanding how actions they take resulted in actual ads they saw later in time. From our study, we compiled a number of user preferences to inform future profiling transparency. In profiling users, platforms should infer if users' activities may be a one-off activity, potentially sensitive or private, or unexpected for the user. For example, would users expect the way they commute to work to be used in profiling for ads? Then platforms should notify users in these circumstances so that users can be in the loop, set boundaries, make corrections, and optimize their ads experiences. Increasing transparency of profiling like so may lead users to have more desirable and trustworthy experiences with ad targeting. More findings, design implications, and limitations of our study can be found in the paper. We're grateful for the funding and support from the Facebook Privacy Preserving Technologies Research Award and from the National Science Foundation. Special thanks to our field study and pilot participants, to Professor Michael Twidale and Professor Shavik Das for providing feedback on our work, and to anonymous reviewers for their work and thoughtful suggestions in the paper review process. Thank you for watching this presentation.